So yeah, big welcome to everyone to our second SAS app developer event. We're hoping to build a community of SAS app developers where we're all building apps in different ways, and we can share ideas and experience. And we're very fortunate and grateful today to have Xavier from France, but we're working for SAS Belgium, but from SAS Institute. And Xavier is very experienced when it comes to building SAS apps. You've probably read quite a few of his articles online on SAS communities. And today we're going to learn a bit more about building apps using MAS. So over to you.
Yeah. Hi everyone. I will demo end-to-end application development. So basically, how you can start with building a model using VA, because most of the people that are developing apps might not have the knowledge to be model developers. So I will explain how you can build a model just using point and click, deploy that model into MAS in order to consume it from a web application. So for those who are not really familiar with SAS and MAS, maybe, MAS is a macro analytic service. So it's there within the VIA environment in order to deploy models to be executed in real time. So you will see that in the demo. I will share my screen. Can everybody see the screen now?
Yes.
Okay, I will just connect to my environment. It's VIA 4. It's the latest release, but not the stable, but the main release, LTS. Try it. There we go. I don't need to be an administrator for this. There is a code there. So basically what I will do is just demo how you can build a simple application for predicting art attack. It's not a nice topic, but it can help. And I use that example because we can really simply use the art dataset that is available in the SAS help library. My environment is quite slow at the moment. I don't know for which reason. So I'm starting up just Visual Analytics. I will start with data, select the art data, click on OK. The data set is selected. Then I will just use an object called automated explanation, and this will give me an idea about the data that I'm using. So I will open the rows. I know from the data set that we have different variables, and in this case we have the status, which is dead or alive, and you see that automatically you have the information about what factors are the most interesting factors or impacting factors. From the data, I know, for example, that the blood pressure status is the same as another variable, so I will remove all the status variable because it doesn't make sense to have redundant data. I will also remove this one, and the weight status doesn't need to be there. So you see here that I have a complete list. Automatically it's updating. It's giving me the information about what is important and how it is impacting. If I click on this, I see the distribution, which is fine. And if I want to get more explanation, I can also extend it. And for example, here I see that 4 factors were removed from the list. I want to understand why they were removed. So the age at death was rejected due to the number of missing values. There are too many missing values also for CHD diagnosed, and the cause of death is a subset. And I see also that smoking has been converted, which is fine. So I have at least an understanding of which factor might be impacting in the in the art attack troubles. So what I will do now is create a model, and therefore I will use the gradient boosting, which is part of VDMML. I will create a new page for that. And from there, I will reuse the same variables. So I will set the status as being the response, and then the predictors. And for the predictors, I will select the variables that we have seen that are important. The 8 was the last one, so I will not use that one. I will use smoking, systolic, and weight. And it will just, for me, behind the scene, calculate and use the gradient boosting model to calculate the variable importance, and also to classify some values being alive or dead. And you have the observed and predicted, which is fine. If I want to get more information, I can again use the automated analysis that SAS has behind the scene to get the information about the confusion matrix, the lift and ROC, the misclassification. And even though I'm not a statistician, I can get information out of here explaining what are the summary, or what is the summary of the data based on the information that we see there, which is fine. I will not go through this because we are not supposed really to demonstrate how VA can help into that, but I thought that it was nice to give a better understanding of what is possible and what is not possible. But of course, here we have also the auto-tune. I will not use it right now because we are not really looking into the performance of the model, but using the auto-tune, you can also run a batch of processes to simulate and estimate which of these options will be the more impacting and which will give the best result. So here behind the scene, we have a model, and this model, I will record it. So basically register the model so that I will be able then to deploy it under mass. So I will call it gradient boosting. It will be saved. And while it's saving, so what is happening now, we are linking this to a model repository. And this model repository will store the model that can be then published or reused within Model Studio or other products. But that's not the objective of today. And the good point is that during the full process here, you see that we can have the complete ModelOps environment. So you are getting the data, building a model, registering the model, and when the model is registered, you can go to the Manage Models. Manage Models, we are moving to SAS Model Manager, where we can have models and also projects. What is the difference? You can register a lot of models and you can build a project for a specific topic. So in this case, it will be art attack prediction. Again, my environment is not really performant. I don't know why. It should be faster. So what we will do is here we will register the model into a project, and from there we will be able to publish the model to mass. So we can just check that our model is available. We see that we have the art gradient boosting. It's a classification model and it was done by me. We will do this within a project. So I will create a new project, and the new project will be art attack prediction. As the name indicates, it's a prediction model. I will store it. I don't need to go and to specify all the specific information here because it's specific to models and it can provide a bit more information. But for the purpose of this demo, there is no need to complete this. So it's creating the project. We'll then, within the project, record the model that we have created earlier. So we will just add the model. We'll make a copy of it, because in that way, if we want to modify the model in that specific repository or in that specific project, there is no impact if the model is also used in another project. So far you've seen that we have just used point and click. There is no fancy hacking, no coding. There is no need to go behind the scene and do something else. What I've done here is just select the model and publishing, and I will publish it to the mass destination. I will replace, just in case the model already exists. The published name is there. It's automatically generated for me. If I want to change it, that's fine. If we have multiple versions, that's also good, because we can or have different versions for the published name, or keep the same version and updating the same. So that means that when we are building our web applications, then we can reuse that published name again and again, even though the model behind the scene has been adapted and is changing across the time. While it's publishing, I will show you what I've done in Visual Studio Code. So basically, I've created a small React application, and I've done this using the Create React app. It's pretty simple. You just run the command line, you specify a few information, and it's generating for you the folder structure. What I've done in addition is create a few more folders for pages, because our application will have multiple pages, a home page, a logon page, and a mass page. I've also created some components for the header bar, a loading component, the mass form, we'll see what it's used for, the mass result, which will display the results, and we have the app.js. So in the app.js, I'm defining some containers, a context. So the context is just there to pass data within the different pages of our application. In this case, we will be using the context to pass the authentication token, because when we are working with mass, we need to be authenticated. There are different ways to get the authentication. If I'm correct, Joe Furby has done a nice tech exchange or a webinar yesterday, and it's now available online, so you can have a look at it to see the different techniques that we can use to authenticate. And as you see here, I have an authentication information. I use a state. I have the token info. I indicate if it's authenticated, yes or no. I'm also using routes to redirect the request to different pages based on the path that is specified, or the URL. In this case, we have the home, the mass, and logon. We can define as many as you want. And we are using the host context provider to get the information. For the components,
SAS VA for a great presentation. I'm not going to stop the video because I don't think I can, but we'll trim it to stop here.